Look up at the night sky. What do you see? Stars, perhaps the moon, maybe a planet or two. But there's one celestial body that outshines them all. It's Jupiter, the king of planets. This gas giant is a cosmic marvel. It's a world so large that it could swallow over 1,300 Earths. Jupiter isn't just big, it's a cosmic powerhouse. It shapes our solar system in ways we're only beginning to understand. This giant planet is like a celestial sentinel. It stands guard over the inner planets, including our own. How? By its sheer size and gravitational pull. It's nature's way of playing cosmic billiards. But Jupiter is more than just a big ball of gas. It's a world of swirling storms and vibrant colors. The most famous of these is the Great Red Spot. It's a storm that's been raging for centuries. From its powerful magnetic field to its dozens of moons, Jupiter never ceases to amaze. Jupiter is a planet of extremes. It's big, really big. How big? Well, it's about 11 times wider than Earth. If Earth were the size of a grape, Jupiter would be the size of a basketball. That's huge. But size isn't everything. Jupiter is also incredibly massive. It contains more than twice the mass of all the other planets in our solar system combined. But Jupiter's not done showing off. It's also the fastest spinning planet we know. It completes a full rotation in just under 10 hours. That's less than half an Earth day. This rapid spin has some interesting effects. It flattens the planet slightly, making it bulge at the equator. It also creates powerful winds in Jupiter's atmosphere. These winds can reach speeds of up to 400 miles per hour. All this mass and motion creates a powerful gravitational field. Jupiter's gravity is more than twice as strong as Earth's. If you could stand on Jupiter's cloud tops, you'd weigh about 2.4 times what you do on Earth. But don't worry, you won't be doing that anytime soon. Jupiter doesn't have a solid surface to stand on. Jupiter isn't just big, it's also a frequent target for cosmic collisions. The most famous of these happened in 1994. That's when comet Shoemaker-Levy 9 slammed into Jupiter. It wasn't just one hit. The comet had broken into pieces. Over 6 days, 21 fragments hit Jupiter. Each impact was like a cosmic bomb. The largest explosions were bigger than the whole Earth. Scientists watched in awe. It was the first time we'd seen a collision between two solar system bodies. The impacts left dark scars on Jupiter's surface. These scars were visible for months. It was a wake-up call. We realized that such collisions could happen to Earth too, but Jupiter's size makes these events more common there. It's like a giant target in space. But Shoemaker-Levy 9 wasn't a one-off event. In 2009, Jupiter got hit again. This time, it was an asteroid. An amateur astronomer spotted the impact. It left a dark spot about the size of the Pacific Ocean. These impacts happen more often than we thought. We've seen several more since then. They remind us that our solar system is a dynamic place. Jupiter's gravity is a force to be reckoned with. It's like a cosmic magnet, pulling in everything nearby. This gravitational pull is what makes Jupiter so good at attracting space debris. But how does it work? It's all about mass. The more mass an object has, the stronger its gravity. And Jupiter has a lot of mass. Remember, it's more than twice as massive as all the other planets combined. This strong gravity affects everything around Jupiter. It tugs on its moons, keeping them in orbit. It pulls on passing comets and asteroids. Sometimes it captures them, other times it flings them away. Jupiter's gravity even affects the other planets. It can change their orbits slightly over long periods of time. It's like a celestial dance, with Jupiter as the lead. But Jupiter's gravity doesn't just pull things in. It can also push things away. How? It's all about timing and position. As objects pass by Jupiter, its gravity can give them a boost. This is called a gravity assist. It's like a cosmic slingshot. Section 5. Cosmic Vacuum Cleaner, Jupiter's protective role. Jupiter isn't just a pretty face in the night sky, it's also a protector. How? By acting like a cosmic vacuum cleaner. Its strong gravity pulls in all sorts of space junk. Comets, asteroids, and other debris often end up hitting Jupiter instead of the inner planets. This includes Earth. In a way, Jupiter takes one for the team. It's like a big brother looking out for its smaller siblings. But how effective is this protection? It's hard to say exactly. We can't count the objects that would have hit Earth if Jupiter wasn't there, but we can make educated guesses. Scientists estimate that Jupiter reduces the rate of impacts on Earth by a factor of 1,000. That's a lot. Without Jupiter, Earth might be a very different place. We might get hit by large objects much more often. This protective role isn't new. It's been going on for billions of years. So next time you see Jupiter in the night sky, remember, that distant point of light might be one of the reasons we're here to see it. Section 6. Not alone. Other planetary impacts. Jupiter isn't the only planet that gets hit by space rocks. All planets face this cosmic bombardment. Earth is no exception. We've had our share of impacts. The most famous is probably the one that wiped out the dinosaurs 66 million years ago. That was a big one. But smaller impacts happen all the time. Most burn up in our atmosphere. We see them as meteors or shooting stars. Mars shows clear signs of past impacts. Its surface is covered in craters. Some are huge. The Hellas Basin is over 1,400 miles wide. That's about half the size of the United States. Mars doesn't have much atmosphere to burn up incoming objects, so it gets hit more often than Earth. Its smaller size also means it can't pull in as much debris as Jupiter, but it still takes its share of cosmic punches. Even the gas giants beyond Jupiter aren't safe. In 2009, something hit Neptune. It left a bright spot that astronomers could see from Earth. Saturn, Uranus, and Neptune all show signs of past impacts. Their moons are covered in craters. Some of these moons might have formed from the debris of massive collisions. It's a violent history written in rock and ice. Section 7. Jupiter's moons. A solar system in miniature. Jupiter isn't a loner. It's got company. Lots of company. Jupiter has at least 79 known moons. That's more than any other planet in our solar system. These moons range from tiny space rocks to worlds larger than Mercury. It's like a miniature solar system orbiting Jupiter. Each moon is unique. They have different sizes, compositions, and histories. Studying them is like exploring a whole set of new planets. The 4 largest moons are called the Galilean moons. Galileo discovered them in 1610. Their names are Io, Europa, Ganymede, and Callisto. Each is fascinating in its own right. Io is the most volcanic body we know. It's constantly erupting. Europa has a smooth, icy surface. Scientists think it might have a liquid ocean underneath. Could there be life there? Ganymede is the largest moon in the solar system. It's bigger than Mercury. And Callisto is covered in craters. It's like a record of impacts in the early solar system. But these big moons are just the start. Jupiter's smaller moons are equally intriguing. Some orbit Jupiter the wrong way. We call these retrograde moons. They might be captured asteroids. Section 8. The Great Red Spot, a storm for the ages. When you look at Jupiter, one feature stands out. It's the Great Red Spot. This giant storm has been raging for centuries. How long? We're not sure, but it's been at least 400 years. That's older than the United States. The spot is huge. It's about 1.3 times as wide as Earth. Imagine a storm so big you could drop our entire planet into it. That's the Great Red Spot. But what makes this storm so special? For one, it's incredibly stable. Earth's storms last days or weeks. The Great Red Spot has been spinning for centuries. It's like a giant hurricane that never dies. The spot is an anticyclone. That means it spins the opposite way of the surrounding atmosphere. This helps it stay separate and stable. It's like a gear spinning against the flow. The Great Red Spot isn't always the same. It changes over time. Section 9. Jupiter's composition, a failed star. What's Jupiter made of? Mostly hydrogen and helium. Sound familiar? It should. These are the main ingredients in stars. In fact, Jupiter is sometimes called a failed star. But what does that mean? Well, Jupiter has a similar composition to the Sun, but it's not massive enough to start nuclear fusion. That's the process that powers stars. Jupiter is close, but not quite there. So if Jupiter isn't a star, what is it? It's a gas giant, but it's not just a big ball of gas. As you go deeper into Jupiter, things change. The pressure gets intense, so intense that the hydrogen changes form. It becomes a liquid metal. This liquid metallic hydrogen is key to Jupiter's powerful magnetic field. It's like a giant dynamo inside the planet. But there's more to Jupiter than just hydrogen and helium. It has traces of other elements too. These include methane, ammonia, and water. These create the colorful bands we see on Jupiter's surface. They also form clouds and storms. The exact mix of these elements can tell us about Jupiter's history. It might even give us clues about how the solar system formed. Section 10. Exploring Jupiter, past, present, and future missions. Humans have been fascinated by Jupiter for centuries, but it wasn't until the space age that we could explore it up close. The first spacecraft to visit Jupiter was Pioneer 10 in 1973. It flew by and took the first close-up pictures. Pioneer 11 followed a year later. These missions were just the beginning. Since then, we've sent several more missions. Each one reveals new secrets, and the journey of discovery continues.